Okay, hello and welcome everybody. I'm Jason Gumpert from msdynamicsworld.com, and joining us today for a session on applied Internet of Things scenarios for Dynamics AX and CRM, we have a returning speaker for us, Alex Anikiiev. He is a technical architect at Microsoft. Alex is a frequent speaker and presenter at events, and he's also an active blogger across a range of related topics. As a returning speaker, when Alex proposed this topic to present today, I was really excited about the opportunity to put it in front of our audience. It's going to be a really unique and up-to-date look at some of the technology that Microsoft will support for Dynamics customers and for their IoT initiatives now or in the future. And in my view, it is a look at the technology and the business scenarios that can, I think, be hard to find presented in a comprehensive way. So really looking forward to today's event. As we get started, I just want to add a couple notes. First, we do welcome your questions and comments. We recommend using the Q&A block you'll see to the right of the main presentation window. And this session is scheduled for 90 minutes. We will be using much of that. Alex will be using much of that time, but we will make an effort to answer questions at the end. So please enter your questions anytime, and we will get to as many as we can at the end of the session. We're also recording today's event. So without further delay, please allow me to welcome today's speaker, Alex Anikiiev.
And I'm very excited to present today on this topic. Again, the topic is Internet of Things and everything which Microsoft delivers, all the services that Microsoft delivers to support this big initiative that many companies are going through right now. So I have a lot of content. I'll be doing a lot of switching between one technology to another technology. The whole idea of this is to show you the broad range of Microsoft services and how this applies in Internet of Things era and different situations and different scenarios with the connected devices. So just up front, we'll tell you that I lost my voice a couple of days ago, so I teach a couple of workshops since the beginning of the week, so I will use a cup of coffee that is next to me. So if you see me drinking something, that's just for to maintain the voice. That's the idea. So we'll start with a couple of slides that I prepared, and this is just to kind of lay out the foundation of what will be presented. And then you will see during the course of the presentation, you will see how I kind of progress from the beginning of the scenario when I typically start with the device, some kind of a device which is connected device, which is intelligent device, enabling intelligent operations, connected with the Dynamics solutions, Dynamics CRM and Dynamics AX in my instance, and then I will go all the way to like, okay, so I collected all that data from the device. So what do I do with this data? So I need to do some intelligent analysis of this data. Then potentially it's a huge amount of data, so I will have to effectively process and kind of to be able to make sense of that data. And then what do I do in addition to this? Maybe I can learn from the data I collected, and maybe I can even predict the future. Another aspect of things is that if you have the data, what will be your options to display and to consume the data in terms of the different types of modern experiences, apps, and different types of representations, visualizations, and such. So I'll just jump into the content. So on the first slide, what you see is just information about me, my name. My name is Alex Anikiiev. This is my email. I'm running multiple blogs. This is the list of main blogs that I try to maintain. So manufacturing blog, it's more like on functional side of things, and then a lot of blogs in the area of enterprise data. And then, of course, I'm also interested a lot in mathematical modeling and optimization and things like that. So on the next slide, this is truly the core of what Internet of Things is and the Microsoft vision for Internet of Things. So many people understand Internet of Things differently. We can kind of simplify it, and you will see in my examples, in my scenarios, how I would like to represent what Internet of Things is. But according to the global Microsoft vision of what Internet of Things is, we playing in like three main areas around improving efficiencies and driving costs down, enabling innovation and bringing all the latest and greatest technologies, and ultimately transformation of our clients' business. And as you will see in the boxes down below, you will see like in improving efficiency, we have heterogeneous client agents, Azure Event Hubs, Azure Intelligent System Service. Enabling innovation is supported by Azure Stream Analytics, Azure Machine Learning, and transformation of your business. This is just some of the examples of the services that Microsoft provides to and enable those direction of innovation. HDInsight, machine learning, Power BI, Office 365. So all this goodness, and this is all delivered by Microsoft, and that makes it very unique value proposition, because all the way from like a device to all the way to the interesting and potentially complex mathematical modeling optimization and business insights, you can use one single vendor, one single platform, and Dynamics just leverages and benefits from all of these services. So at this point, if I go to like very particular example, let's say of manufacturing system, which has multiple layers. So this is one of the representations of layers. So we start with the equipment sensors, then we go to PC, PLC, SCADA, MES, MRP, ERP, and it's all like different layers. There's interconnections between those layers. And my main question in the light of those layers is, so what role cloud may play in this setup? So I'm trying to understand, like, having Windows, Azure, and this cloud platform. So how many benefits and what I can gain from using cloud in environments like this? And we can speak about different industries as well, such as distribution, such as professional services, public sector. So like those services, they're uniformly applied to different types of scenarios because they just get things done. They allow you to get your job done. So that's the idea. And I will highlight as I go. I will highlight multiple specific industry examples when I go through my scenarios. On the next slide, this is just a disclaimers about myself using Lego Mindstorms EV3 robot, and I'm just saying that it's a trademark and or copyrights of the Lego group, as well as the Skylight is the trademark of the APX Labs. That's one of the, so everyone knows like a Lego Mindstorms and so on. APX Labs, this partner is becoming increasingly popular because what they do, they build software for the smart glass. So I'll show you in my scenario how the smart glass can be applied in industrial scenarios. So we're getting closer and closer to the core of the scenarios, and I have two scenarios, and I will show you as we go. I will show you elements of each of them. So in the first scenario, this is more like a manufacturing scenario when I have different types of connected devices. Maybe I'm manufacturing different speakers of different colors, and I'm using the power of the cloud to collect the data from the machines, and then I'm using Dynamics basically to organize intelligent operations around that data. And as I collect the data, I can push necessary amount of data to Dynamics from the cloud, and then do some activities around this. So what I'm using in particular, and you see how this transforms into those IoT buckets. So cloud is used to improve the efficiency, different types of Dynamics applications, as well as mobile apps I use to enable innovation for the workforce and the workspace. And then from the perspective of transformation of client's business, of course, we can use a variety of cloud services from Microsoft, such as Power BI, HDInsight, machine learning, and optimization using software. My second scenario is around using the smart glass. And imagine now we are in field service and the maintenance scenario when something gets broken and you dispatch somebody to go in the field and repair something. And maybe you truly need to have your both hands free, and you need something like a wearable to wear and get information just readily available for you and be able to interact with this device almost like use Kinect, like without touch, just by doing some gestures or maybe head movement, which is exactly the case for my scenario. And again, I'm using a broad range of services, which in this case includes Azure Media Services to publish the rich media content, such as, let's say, training for somebody wearing the glass, to enable somebody to watch a video straight on the glass in front of your eyes, how to do some like type of repair. I'm using big maps for the field service dispatch. I'm using document management and SharePoint sites to display and make different types of documents available. And then I may use even Cortana activation if I have my phone and I want to say to speak to Cortana and let Cortana update something like a service case for me back in Dynamics CRM, let's say. And in this case, I'm using APX Labs Skylight technology, which is the software for the smart glass. So when you see what I do on the smart glass, that's the software is built by APX Labs. So at this point, I'll just get into my first scenario, and let me do a little bit of preparation. I'll show you my equipment right now. All right, so I'll adjust this a little bit. And I will bring up the camera app just so you can see what I see. All right, I'll just adjust this. So basically what I did, and you see the smart glass is on my table right here next to the EV3 robot, the Lego robot that I will use for my presentation. So the idea for this presentation is that I have a manufacturing equipment, and I'll be collecting data in real time from that manufacturing equipment. So I have a different types of stickers I'm producing of different colors. And I have a conveyor belt, which I literally built using Lego Mindstorm, EV3 Mindstorms robot. And I will launch, so I'll first scan my products, and you will see I'm using Windows 8 Modern app to basically collect the data from the device, from the equipment using a color sensor, which is right here. That's the color sensor. And then I also have an ultrasonic sensor, which is used more like for the maintenance scenario when my manufacturing equipment of this dispensing unit, which is this one, will be stuck, let's say, and I have to report the maintenance request back to Dynamics. So for this purpose, I can use the ultrasonic sensor, which basically measures the distance, like if something is in front of them, in front of this sensor and it's not moving, I'm just making an assumption that after like certain period of time that this is a breakage. And then the conveyor belt will move from the left to right and vice versa. So I program that, and then it will dispense units of my speakers to the packaging area or to the container, which is down below. And this is how the scenario will work. After I implement and after I go through the execution phase of this, I will show you how the data gets collected in the cloud, which is the Microsoft Azure mobile service with the database backend. So let me just position this well for you so you can see it as the live presentation. So if anything, okay. So the first app I built is called Remote Control. And before I do this, actually, let me launch the robot itself. So I'll just get back to the camera, and I will launch the robot here. So when it launches, I'll be able to wirelessly connect to this robot. So there is no like wires here going from the robot itself to my computer, but I can easily connect wirelessly to this robot. So it will take a few seconds for it to launch. And after this, I will speed up with the execution cycle.
Hey, Alex, I'm sorry to interrupt. A couple people are saying they're having trouble hearing you. Can you just make sure you're as close as possible to your microphone?
Is this better? Must be better because I'm very close. Okay, so this is what I have, and at this point, I will launch the app, and I will use the snap view of Windows 8, basically like this. So you will see at the same time what's happening with the robot, at the same time what's happening in my app. So connect to this robot via Bluetooth. And at this point, you see that this is all touch sensor, so if I touch something, you will see that it's reacting to what I'm doing. Same thing is here, right? So I'll first start my what I call register cycle. So the register cycle will allow me to scan my products using my color sensor. And you will see as I go and scan my products, it will show you what colors of product I'm scanning, right? So this is green, this is yellow, this is red. So not only it's a lot of fun to build scenario like this, but it's a lot of application, like you see almost like a mini plant on your table, and you can see how cloud plays an important role in all this stuff, collecting data in the most economical way and providing a lot of benefits. All right, so this is my equipment that scans my products, and then I will execute the report as finished cycle to essentially start my robot. So all hands-free, no wires at all. It just starts my robot as it goes and dispenses those products into the packaging, I'm collecting this data in the cloud. So right after this is done, I will go and log into my Windows Azure portal, and I will show you this data, how this data gets collected in the cloud. So a few more runs of it, and you see that it went all the way to the right, and then it turned back because the touch sensor indicated that you reached the right edge of this conveyor belt, and then it dispenses the last unit, gives me indication that it's done, and then I can just simply close the app, close the camera, come back to my scenario, and actually at this point I will show you that this data effectively got collected from my equipment in the cloud, and I built another application which allows me to see that this data got collected. So this small application is called Machine Log, and you see that I actually did 2 runs, one in preparation for the event and one with you just right now, and it shows you that I collected yellow, green, red, blue, and this is actually reading information from the cloud, from the mobile service with the database backend in the cloud. So now let's take a look how this information looks like in the cloud, because this is all cloud powered. And actually I'll go ahead and I'll go to the portal. So I'm using my MSDN subscription in this case, and everybody who is not using this and who has an MSDN subscription and Azure credit, I highly encourage you to try lots of different types of Windows Azure services in the cloud, because if you have this credit, just go and use it for your benefit. So basically I have the mobile service right here, which is the IoT, and then I go to the log table, and you will see how the data got collected in the cloud about this login information about what was produced based on my execution cycle. I also have an item event table which sends me messages, and I will not go through the maintenance cycle, which you saw it, I also implemented. It gives me messages about maintenance, like when this machine requires maintenance, then I will be able to go in and see that maintenance is required. So at this point, I also built, and I'll just close this out, I also built a small connector that collects the data from the cloud and pushes this into Dynamics, the Dynamics CRM or Dynamics AX. So let's see how this looks like. So it's very simple representation, a very simple implementation of this capability to track information about what was logged in Dynamics AX. So just a very simple project I implemented, and it allows me to bring up this log and see, okay, so this is what I produced, exactly what I need. and I established this connector service, which is essentially speaking with Dynamics AX and Dynamics CRM via web services. I established this as the Windows service that runs on the Cadence. So this is the AX point of view. And if I go to Dynamics CRM, I'll show you similarly, I built this for Dynamics CRM. And for Dynamics CRM in particular, maintenance scenario makes a lot of sense because Dynamics CRM comes with the service module with the service cases. And let me just log into Dynamics CRM this time. And when it lets me in, we will see that I also built this small module which is called Internet of Things into Dynamics CRM online. So if I go here, Internet of Things, and then this is my active log, which is essentially what I just collected from the machine into the cloud, and then I push this, maybe the whole information or maybe a subset of information which makes sense. I push this into Dynamics CRM for operations. But you can collect in the cloud in a very economical way. You can collect a lot of data, and then the benefit of collecting this in the cloud is that later on I will use this cloud data for my analysis, like for my big data analysis, for my Power BI, for my visualizations, and things like this. So that's a quick example of like how you can easily collect the data from the machines, visualize this using modern experiences and applications, push it into leveraging web services, push it into Dynamics CRM or Dynamics AX, and it literally all depends on your scenario that you implemented. So we finished with this piece. The next piece is I want to shed even more light on the apps that we have available. So let's say for Dynamics CRM, if I'm on the go and if I want to review my service cases assigned to me or available for me to consider, I can easily, let's see, downloads. And then if I go into my active cases, I can see those cases and I can review and take some action and select the view of my interest. Let's say I want to see all cases. And one of the cases here will be basically if my machine sends information about the case for the maintenance, this will show up on my let's say Surface device or any Windows 8 device, and I can, using this experience, I can take some intelligent actions. This is from the using Dynamics CRM Modern app and from the maintenance perspective. But if we come back to the production control example using Dynamics AX, we also have app which is called Production Control. And actually this app, so I'm launching right now, it's connected with Dynamics AX deployed as infrastructure service on Windows Azure. And as I log into this app, I'll just show you that this is the real data coming from AX for Luis Alverca, and I'm using his badge ID, which is one-to-one, and using standard demo data from Dynamics AX. And from here, I can do some very interesting things in terms of like punching on the jobs, taking breaks, and punching on and registering my time against the indirect activities and things like that. So you probably saw this app working in a demo mode, but it's quite easy to establish the real connection for this app. And this is the way you do it. So basically, you specify the service address, which is the WSDL or like the service address, the HTTP. I'm using HTTP protocol, or maybe using HTTPS protocol. And then you provide the service, the username of the service account, password, click test connection, and select the company of your choice. And if you go back to Dynamics AX to review the configuration of this, it's quite easy. So if you're using standard demo VM, just go down here to Services and Application Integration Framework. There's a service that comes out the box, which is called, let me just go there, go open Workspace, and then Services, and then GMG, Shop Floor Service. It implements all the operation that you may need from the shop floor control perspective. And this is essentially what is being used by the app in that I just showed you. And as I described this inbound port, so this is how it looks like. So basically you create a new inbound port, you specify the adapter, which is the HTTP in my case. You get this service with the URI, and this is what you supply in the app. And then, of course, the service operations, I included all the service operations starting from clock in, clock out, and all the different types of operations for that JMG shop floor service. You can also actually even modify the business logic in the service, and all you need to do after you modify is to recompile CIL, and you have your own like personalized business logic against working against that application easily right away. So very easy to do, very nice feature, and it works, and it allows you to do some very interesting stuff and be productive with the shop floor control activities. So that's in terms of the apps, so we're getting closer to the data. So we collected the data, we had it in the cloud, we potentially pushed some of this data to Dynamics, we generated some data from within of Dynamics, used this in the different scenarios, production control and maintenance, all relative to like Internet of Things and connected devices. So my next point is I want to visualize this data. So what does it take me to do to visualize? Let's review that. So I'll come back and to my templates. And for this webcast, I prepared a couple of templates using Excel because everybody understands Excel. So if I show this in Excel, and of course leveraging the power of technology in Excel 2013 and Power View technology for this rich visualization, and then this kind of provides me with the bridge to the cloud Power BI service that I will also highlight. So this is a very good next step for me. Okay, so I have the data, so what do I do with this data from the business intelligence perspective? So you remember that we had two main scenarios around login event about like the maintenance of the machine and so on, as well as the login of maintaining the log of actual production. So let's see what you can do in Power View to very nicely visualize what's happening with your data and how you can easily visualize this. So I have this data, which is the Excel in Excel spreadsheet as Excel table. Of course, you can retrieve this from Dynamics AX very easily using template and using add-in in Excel, and just to specify the data source of your choice, being a query or being a table, and then retrieve all this information. And as you have this template, then you will be able to refresh it every time you open this up and have a fresh representation of the data. So in this case, I have information just like I collected from the cloud: order, product, quantity, color, size, batch, serial, number of transaction date, and machine. And I built this Power View visualization. So this takes literally like a few minutes to do. So that's the first kind of visualization, first approximation, and I hope many of you had a chance to see Power View in action already. So Power View allows you to add different types of charts and visualize this very nicely. So if you like go and add some charts, and I did add chart for like pie chart. There's a graph and there's a stack chart. So basically, I'm using in all these three representations of the data, and you see the table which allows you to, for each chart to select like what the data you're specifically working with. So this is looking at the same data set. So now watch me doing this. If I, let's say, select the blue color, this is where I can easily see that my blue color gets produced on demo machine 1 and demo machine 4, because that's just a different kind of point of view and angle of view at the same data. And if I click on what's going on my demo machine 3 on the floor, this is what gets produced on demo machine 3. And you see that this graph also changes and reflects like what's going on with my data. Like this is the blue, this is other color, and such. And you can using this Excel template, you can compose those graphs very easily, and then just by like selecting what data you would like to use, and then this will show up in appropriate buckets down below, and this is how you can easily and very nicely visualize more or less like a dry set of data as it's presented here into a very rich immersive experience that like with a one click it gives you a dynamic update of the data in conjunction with what you've selected. So a very nice type of visualization that we can build using Power View. Another example is around events. So this is more like I have, I start with this spreadsheet. So this is what I may collect from my machine. So this is number of successful runs, number of maintenance requests, number of failures, power outages, and so on. So the problem, so we have a transaction date, which is great. We have different types of messages, reasons, and statuses. The problem with this data set from the visualization perspective is that I do not have a numerical column to kind of represent. So typically I need something like quantities or amounts in dollars, like to build those nice pie charts and so on. All I have here is text. So what do I do with this? So my next step, logical step, if I want to visualize this in Power View, would be to build a pivot table, and that's what I did. So the purpose for the pivot table is to aggregate the data and give me like a number of successes, number of power outages, and so on. So then I have this set of data, which is much easier. It has a lot of numerical values, and it's much easier for me to visualize using Power View. So let's see how my Power View for the event analysis looks like. So when I build this set of graphs, you will see that I have, let's say, per date, I have a different types of events, and I have, let's say, this is for the 1st of January, this is for the 2nd of January, and so on. And I also have a different type of graph down below, which is like the stack graph that shows me how many power outages per day. So this gives me a good insight into what's going on the floor. And again, I build this myself. You can leverage a lot of existing graphs on existing role center pages in Dynamics AX when it comes to production control and MES, the manufacturing execution system activities. But I'm just showing you how easy it is to build something like that. So you remember that I highlighted and I kind of stressed on the importance of kind of getting from this representation, which is essentially what people typically get from the machine, not the numerical values, but some kind of log, into this representation through the pivot table. So now imagine adding a little bit more kind of real life to this scenario. Imagine that I have 3 or 4 types of machinery all producing different types of logs. So it's not even, it's maybe like it's a text file. Maybe it's some very weird instructions like a hexadecimal codes for my errors or for my successes and so on. So there is no even a way to kind of represent this in a relational structure as a table. So sometimes you truly have something like this, right? So I go to like this, and this is what I get from my machine, like some kind of log, which is not even structured. And it may be like that you collect gigabytes of those logs during the day. So how do I go about this? How do I make this happen? So for this reason, I will come back to the big data example. And for those of you who never saw big data in action, this will be quite eye-opening of what you can do with the big data. But I'll just hold on for now until I complete my Power View scenarios with a couple of more examples. So I showed you something very simple, but in fact, using Power View, you can build a very interesting representations of the data. So my next example will be in the distribution domain and warehouse management domain. So imagine that you have a data and you do optimization around warehouse slotting when you need to put your fast-moving items, which at this point are at the back of the warehouse. You need to move them up front and to the front of the warehouse for better picking activities and optimized picking activities. And your slow-moving items will have to go vice versa, like from the front of your warehouse to the back of your warehouse, because you don't have enough demand for those, and you don't need to waste your space in the front of in those picking and staging areas in the front of the warehouse for slow-moving items. So I have this data set which I, again, collected from Dynamics AX, and I have product, warehouse, location, the coordinate of my location, the quantity of the goods stored in that location, plus the year and month, which is which allows me to add this timeline kind of to this analysis. So if I go to the Power View, so first thing you notice is that there is a background, which is exactly my layout of my warehouse. So Power View allows you to do the background image, which is quite nice. Then I have aisles, and I have aisles and basically X and Y axis modeling where my product sits in the warehouse. And what I can do with Power View, the feature is called, and the type of the graph is called scatter plot. I can build visualization. So basically this play axis, which I use the year and month for the play axis, allows me to do something like that. So it allows me over time to see how my products were moving in the warehouse. So it seems like product B was initially at the back of the warehouse, and it moved all the way to the front, and vice versa. And you can select, like, you can build a trajectory and see like what essentially is going on in the warehouse. So very interesting and practical example. The other related example is in the same domain, warehouse management, and this is around heat map. So the heat map allows you to, basically I have bubbles. I'm using exactly the same data set. And this time, I have a different sizes of the bubbles, and over time, so I'm also using the Excel conditional formatting here to show me like where the quantities are. And then in Power View, again, using this play axis, the same, slightly different combination of how I use the data, but essentially it's the same data set. So it allows me to build a heat map that over time shows me those pulsating bubbles, and I can put my focus on one of them and see like the shade and how it was growing and how it was shrinking and so on. So you can analyze, as a warehouse manager, you can analyze your data much easier in a very creative ways. So this is just a couple of hints for you guys about how to use Power View in a very like very specific industrial scenarios around manufacturing, distribution. You can use this in retail and professional services, whatever you, public sector, whatever industry you're working in. So now I'm back to the big data. Hopefully you still remember my challenge with this log and the way I need to basically analyze this data, and I still need to know like how many warnings and errors and per machine and so on. So how can I optimize, and how can I work with the non-structured data or semi-structured data, and potentially like terabytes or like gigabytes, terabytes, or even petabytes of data that I collect. So I may be collecting the data and I'm just wasting my space, the storage space and efforts without being able to analyze this. So for this reason, I actually built, I'll go back to my, one sec, I'll go back to my example with the home. So log out of here, and I will go back to the Azure portal, and I will show you the HDInsight cluster that I built, which is the HDInsight is the name of the Microsoft service, which is essentially a full implementation of Hadoop, which is the big data tool in the cloud. So if I go back here, I'll be able to show you how my cluster looks like. And then I also will show you the .NET application that basically connects, grabs this data, connects to this HDInsight cluster. And HDInsight cluster gives me this kind of infinite computational power. So this is my HDInsight cluster, which is running. And I can define like how many machines and how many VMs I would like to. So let's see my credentials for the HDInsight cluster. If I'm, yeah, a different type of credential I'm using here. So I'm logging into the console for the HDInsight cluster. And at this point, I will switch back to the .NET application which I built, which essentially connects to this HDInsight cluster, grabs the data, and does what is called the MapReduce algorithm. So the idea is that I have this very non-structured data that I want to analyze using regular expressions. And first I want to map the data. So like what am I looking for? So I'm looking for something which stands in braces. And I could be looking for something like a 0x, something like the hexadecimal instructions or something. But I'm looking for the messages coming in square braces like this. And I want to know, and this may show up in a very like arbitrary way, but I know that every time like the error shows up, it's an error. And I want to be able to calculate how many errors potentially per machine I have. The second procedure, and you see it's just a few lines of code to implement this. The second procedure is around reducing. So reduce, as I map my data and I found what I was looking for, I need to aggregate this into buckets. So this is what the reduce does. So from each of the buckets, it calculates the amount of errors, amount of warnings, and such. When I run this application, all it does, it connects to the HDInsight cluster. It starts the processing, which may be like processing a huge data set of like terabytes of data within a matter of like a few minutes. And then it gives you result back. So if I start this, there's the .NET API, of course, for the HDInsight, which I'm using here. And you see that I'm just launching this procedure. And as I go and execute this, you see that the output folder here it will put the output into webcast folder in the file browser, which I will just switch to in a few seconds as my procedure completes. And it will give me back a file that I can parse out, but this file will have those aggregates. So I will not be dealing with the potentially like 10 different files of a huge size. It will just give me a simple small file that will tell me number of errors, number of warnings, and if I want, I can include this per machine. And this gives me this the third step from my event analysis without a need for me to go and manually create a pivot table and do this data massaging and then copying the results of the pivot table analysis into a separate spreadsheet. And only after that I was able to use the Power View to visualize my numerical values. But with the Hadoop, with the computational power in the cloud available to you and being able to process terabytes and petabytes of data within a very limited amount of time, it gives me this also the last step right away. So from here, I can easily go and visualize like in Power. File browser under my storage account and under my user, I will have the webcast folder, which has this part 00 and success indication. So then if I open this file up, you will see how it looks like. So it looks like I have 434 errors, 2 informational messages, 816 warnings, and so on. So I can take this now and easily go back to my event analysis and jumping through 3 steps of what I had to do to get here. I can get to this representation of the data right away. So the big data, it has also multiple components, and I'll just very quickly jump through this in my deck. So we saw the Power View analysis for the log. We saw the interesting things about animations, and then the big data again. It consists of multiple things. So MapReduce is the programming model and API that allows you to do this implementation of MapReduce algorithms, and I showed you the .NET piece as well. And then it also has multiple other pieces such as Hive, Fake, and there's even the file system, which is called HDFS, the file system for Hadoop, which is specifically designed to store lots of data. And then Pig essentially is a scripting model that allows you to do scripting against Hadoop implementation. And the Hive is the implementation of the data warehouse. So the big data story from Microsoft is quite robust. And on top of that, you can apply different types of rich visualizations and do some very, very interesting stuff. So once we got to this point, I want to aggregate this data and represent this as a dashboard. So for this purpose, I will use Power BI Cloud Service. And it allows you to connect and explore the data, monitor the data, and share the data as well. So let's see what I can do about this. I'll just sign out from here, because I will need to use a different credentials here. And I will speed up a little bit, but still believe that we have enough time to cover the whole content. So the Power BI and the idea behind this. So I'll log in with my credentials, Stan corporate credentials. And as I have my Power View reports built out, I can combine them in the cloud into the dashboard, which will be available in the web browser, which will be available on my Surface as a modern app and things like that. So all I did, essentially, I created what is called, and this is, I believe, where I have this. Yeah, here's the Power BI designer file. There's a small client component that you install, and then it allows you to build kind of the metadata representation of how your dashboard should look like. So this is called the Power View BI Designer, and I can get data from various sources, including the web, Excel, SQL, Azure, and whatever you want. And this is how I built this file, just by simply saying I need this to grab this data, let's say from Excel or from one of the cloud services. Once I built this file, I uploaded this file into a Power BI cloud service. And actually, this is this file. And as I look through this file, I can see, okay, this is what's included in this file as the reports. And then when I want to pin something, like I like this report. So if I want to pin this report to my dashboard, that's the way I do it. Like pin to dashboard, and this shows up here. Then I can share this dashboard with my colleagues. I can do some like data monitoring. It will refresh itself as the data gets updated and so on. So that's exactly what I built in Power View, but now it's available through the Power BI Cloud platform and cloud service. And I can grab the data from Dynamics CRM. There's a connector to Dynamics CRM, the standard one that you just connect and consume the data from Dynamics CRM. And it comes with a lot of pre-built dashboards. So this is the website, and the way I connected dots between like what I did in Power View and how I actually this is the way you share, and then some of your colleagues may get the email like this is the way to access this if you grant access to this particular report. Not only this, I can go to my Power BI, and if I put my my reports into a SharePoint Online, which this is what exactly I did here, and you see that there's the Alex IoT and the SharePoint Online, then I can easily like connect those reports and display those reports in a modern Power BI modern app, and this is what is going on. So it's reading the real data, and it's supposed to load this particular report, and the experience is just like I showed you in, and it seems like some trouble with favorites, but this is still working. Maybe not all of my reports were able to synchronize, but this one was successful, so I can easily see like how this is all working. So this is the Power BI modern app that you definitely want to leverage for like displaying and creating dashboards and making them available to people. So we covered a lot of ground, and at this point, I want to switch to the machine learning. And we did like a big data analysis with huge amounts of data with very quick computational power in the cloud. We did this visualization with Power View, different industry scenarios, put this into a cloud as cloud dashboard available on different types of devices, different types of user interfaces. And now I want to actually use some of the data that I have to predict the future. Can we do that? We can. So basically, in my example, I'm explaining that the machine learning is also one of the services that Microsoft provides in the cloud. So if I go back to my account, just give me one sec. And I will log into the Azure portal again. And of course, you can have this under one account. It's just in my case, I just prefer to like separate this between accounts for the better clarity when I work on different types of scenarios. But you can have everything under one subscription and minimize your effort of switching. So I'm switching just because it's a different dev environment that I'm using. So as I go to the machine learning, this becomes even more interesting. So I have a few examples. Let's review some of them. So I have a first example of as I implemented the machine learning algorithm for regression. So the regression basically allows you to, what if I have a data set like this? I have order, product, quantity, color, size, batch, serial, transaction date, machine. So you probably noticed that there is a zero quantity for the last records. So I know historically, and this data set may be much bigger than this one, because that's just a very simple demo data set. So imagine this is all my historical data, and this is the data that will happen in the future. So I want to know how many, based on my historical production history, how many speakers of color blue will be produced on different machines. Because my business supposedly is seasonal, and I know that there's some correlation between parameters of like what I do and maybe a time and so on. So can I do that? I can using machine learning. I can predict, and I can ask the system what will it be in the future. So this is my machine learning workspace, and I will open this workspace in ML Studio. ML Studio is a user interface that allows you very easily build experiments. So like in regression situation, here's my experiment. I also have a data set, which is the Excel spreadsheet, but it may be a cloud data set that you can consume as you collect the data into the cloud. Or you can connect this with a web service and grab the data from Dynamics straight. So this is my regression analysis. So this is the Alex IoT regression file, which is this one. Then I say I'm focusing on certain columns from that data set, being color, quantity, transaction date, machine, and order. The reason why I'm saying this is because I'm indicating to the system that I believe those variables will have some correlation between them. So I want system to build basically the trend, like based on all the correlation, all the relationship between when something gets produced on which machine in regards to which order of which color, and ultimately I want to know the quantity. Then I say I want to split my data set, which is this one, into 84% and 16%. 84% is my historical data. This is 84%. 16% is my data that I'm going to predict. So after this, I say I want to use the linear regression, which is like a straight line based on the number of observations, and it will, based on the straight line, it will guess and it will predict the trend. Then I train the model, score the model, and evaluate the model. And as I go and execute this experiment, so this is as easy as just this. It will just go ahead and read the data source and apply the linear regression algorithm to train the model on the historical data set. Then it will score the model, and it will evaluate the model against the evaluation actually. So scoring is the step that I need to get the results. So this is my projected quantities. So what it says that you say that you don't know. That's fine. But I say that based on the historical data that I have, you will have about like 3 items produced on that date of speaker of color blue on the demo machine 1. Same here, 2, 3, and 3.5, and you can say like 3, and like roughly 4, and roughly 2. So that gives you the prediction. And evaluation allows you to evaluate against actuals. So if at some point, or if you want just to prove that your model is working, then you can put those values here, and it will give you the basically the deviation between what system predicted it to be versus what it was actually in the reality. The second example, and the regression is very good in predicting numerical values, such as, let's say, quantities or amounts in dollars or anything which is like a real or flawed type. The next example is the classification model that I built. Classification, I added one more column, and I say that I have a seasonal business as well as I also prioritize my orders. And depending on the type of the order, maybe depending on the type of the customer and color that gets produced, I want to prioritize it. So I added one more column. And it has only 3 attributes, 3 values: low, normal, and high priority. The idea is the same. So I want the system to predict what priorities will be in the future for like these records based on the priorities in the past. Because my production manager always tends to put some like for certain types of orders, for certain types of products, he or she tends to put a high priority, let's say, or low priority. So I can easily like catch this pattern in his behavior, feed this information into machine learning, and let machine learning even predict, like not even to bother him, but just saying like, this is what you've done for the last 2 years. That's likely what you will do for these orders, because that's the way you do work. So I will be predicting in a classification model. I'll be predicting basically the values for priority. And the classification models, it's very good, and algorithms for classification and machine learning, they are very good in predicting like a finite number of outcomes as opposed to something which is like a numerical value for regression. So let's see what we do and how we do that in machine learning. So I go back to the set of experiments and go to classification. Similarly, I have a similar structure, but this time I'm using something from the classification set of algorithms. And this is all like drag and drop. So you can drag and drop, and pretty much like very user-friendly experience. And you can drag and drop some elements on the canvas, connect them, and then you launch and run your experiment. And while I'm still remembering about this, so it's so easy to convert this experiment into a web service. It's just a couple of clicks in the wizard that you have to go through. You specify what data comes as the input to your machine learning experiment, and what data will be coming out as the output. So then it publishes this. The machine learning studio publishes this experiment for you as a web service, which you can easily call from your like external applications or Dynamics CRM, Dynamics AX, and have all this intelligence built into your Dynamics products. And of course, we use this heavily for like the machine learning algorithms, heavily in Dynamics platform for like telemetry, and I can provide more specifics and implementations of like using machine learning in Dynamics AX. Like the demand forecasting is machine learning implementation of the machine learning algorithm in Dynamics AX, which means that if you use demand forecasting in 2012 R3, you using machine learning, which is quite interesting for people to realize. So then I launch this experiment, and it goes through set of steps, trains the model with the same principle, 84% versus 16% of prediction of what I'm trying to predict. And I'm using the multi-class logistic regression, which is one of the variety of classification algorithms that we have available. So the interesting thing here is that it says the priority is low, which is good. I mean, actually the scored labels is low, which is what I, as a production manager, actually predict, or like what I would put in there. And then, in addition to this, it tells me the level and kind of like the confidence level, probability level for this to be low. So it's our argumentation of why it's slow. Slow because it thinks based on historical data that with a 76% of probability it's going to be low. So it's giving me even indication of like how confident the system is that it's going to be low. My last example is even cooler because now we have two ways and two options to do learning in machine learning. So one is called, as I was trying to explain, supervised learning, and this is what I showed to you, regression classification, which means supervised means that you tell the system that, let's say, I want to predict quantity or I want to predict priority. So you know what you know the domain, you know what you're speaking about, and you tell the system what to do. And actually, just to like support this statement, if I go to classification, the place where I say what I want to do is this. In the trained model, I say, I want priority. Tell me the priority, nothing else I'm interested in. So this is called supervised learning. Unsupervised learning means that you just have a bulk of data. You have no idea of what the outcome will be. You just need to cluster them maybe into two different buckets. And let's see how this is done. So you have a very limited knowledge about the domain, and you want the system to suggest, like, what am I doing with this at all? So for this purpose, I have a clustering algorithm, and I have, if I go to my clustering, this is what I have. So I have information about machines. I have information by date, how many failures, maintenance requests, power outages, and successful runs I had. That's my data set. From this data set, I want to say, machine learning, can you please tell me which machines are performing well and which machines are performing bad? Because I want to take a look at the bad machines and not to waste my time with the machines which are performing well historically. So can I do that? And just to, like, at the glance, to see like which machines are good, which machines are bad? I have 5. Probably not so easy for me as a human being to do that, to do this analysis. In fact, if I go and supply this data set to the machine learning algorithm, and I say, for the clustering, there's one of the classic algorithms which is called k-means clustering. And if I say, this is my data set, this is what I'm looking at, I want to look at, essentially when I'm training my model, I want to look at the proportion between failures and successes. And I want this to be an indication for me to make a decision about how I'm assigning this to different clusters. And when I'm assigning this to different clusters, I will use number of centroids. Basically means how many buckets I want the system to like cluster that data into. So I just need 2 buckets. And because I'm supplying the proportion of failures and successes, I know that this will be based on proportion because that's the data, exactly the data I supply. So number 2, number of buckets plus the data that I supply gives me a good confidence that the result that the system will give me something about the performance of the machine. And if I look at the result, if I run this experiment, and if I look at the result of this, it's quite fascinating, by the way. So like this is what I had, right, initially. That's my initial data set. And then as I look at the assignments, this is the end result. And I'm just showing this to you as a screenshot instead of running this, save some time. And if I now put the cluster next to the machine, you will see that machine number 1 belongs to one cluster, the same with machine number 3. And there are 3 machines in the cluster number, which is the next one, number 1. So 0 and 1. So this does not give me enough. But if I just look at this graph without, and even with the assignment to the cluster, but still, like I want to prove. So what I did as the next step, I actually, because this is what I supplied, the proportion between successful runs and failures. So if I put this onto the graph like this, and my x-axis this is my number of successes. And my y-axis, this is my number of failures. So now if you look at these machines, and based on, again, failures and successes, if I put those dots onto the graph, this is how the system clustered them, which makes a lot of sense, by the way, because basically the contribution from successful runs for machine number 1 and 3 is bigger than, so they're having much less failures as opposed to machines 2, 4, and 5. So I guess there is no doubt that these machines are performing not so well, so I have to look at them closely, and I don't need to worry about these machines because they are performing good. And this whole thing became available because of this analysis. So I can imagine now you have hundreds of machines, and you have terabytes of data to analyze, or you have, let's say, different types of complex characteristics, which is not only I want to analyze based on failure and successes, but I also want to factor in power outages and maintenance requests. And those may be those third and fourth dimension, which is not possible even, like if it's 3D, I can do like a third dimension and do some 3D modeling. If it's 4D, it's kind of challenging for me to do 4D modeling because there is no way for me to, like in a 3D space, to display 4D model. So machine learning allows you to comprehend and work with the data sets which is beyond of the human comprehension, and then analyze a lot of different data, a lot of different correlations using the best algorithms which Microsoft produced and developed, the research group developed for like Xbox and Bing and some other sources for Azure, and then now it's available as a service, which is a great news for us. So very quickly, just to close this topic, I think I spoke about the importance of machine learning, and in terms of the demand forecasting in Dynamics AX 2012 R3, it's implementation of the machine learning, by the way. So you train the model, you score the model, you evaluate the model. You train and score when you do when you calculate the statistical baseline forecast, and you evaluate the model when you do basically the calculation of the accuracy. So that's exactly what happened. So what I did, I took a demo VM with its setup in USMF company, and I ran, for one of the products, I ran demand forecasting using different algorithms. So ARIMA is one of them. It gives you like a very nice long-term prediction, works well on the long-term prediction horizon. ARTXP works well with the short-term prediction, so the same product, but just using a different algorithm. And I used also mixed. So mixed basically selects the one that best applies to the situation, to the horizon, whether short-term or long-term, and so on. So then I put this on the same graph, and the result is quite interesting, and it shows that the demand forecasting in AX works just perfectly, because look at what happens with ARTXP. Because of ARTXP, it's more like it's tailored towards short-term prediction, and it's more reactive. And I'm using this on a more like a long-term horizon. It just spiked up, and you see how ARIMA and Mix provided me more like accurate and more kind of relaxed forecast, let's put it this way, and ARTXP just like exponentially went up. So this means that you have to truly be kind of careful and what algorithm you apply on which horizon, because in this case, I applied the short-term algorithm, which works the best, and it's very reactive short-term sensitive algorithm, which is ARTXP on a long-term horizon, and I may potentially get a very inaccurate results. But if it would be on the short term, my ARIMA algorithm would not catch some of the interesting deviations and signs that is going to be the spike in demand. So that's a very interesting view at demand forecasting in Dynamics AX 2012 R3 and how this works in practice. And you don't need to go far. You just go and use a demo VM data set to do analysis like this. Very, very much fascinating as for me, and eye-opening. And it allows me to explain the value of demand forecasting and why it's important and how this can be fine-tuned and tailored and used for good. My next example will be, so we discussed like how we can do cloud, how we can do visualization, dashboarding, machine learning, big data. My next example is, what if I have a lot of data and I need to do optimization? Can I apply some mathematical algorithms for optimization? One of the examples of how we use optimization in standard, let's say AX112R3, is the constraint-based configuration. So it's a constraint satisfaction problem that gets resolved in the product configurator in AX112R3. And essentially it's using Solr Foundation behind the scenes. So in my example, I said, let's consider example when I have a bulk of data and I have a job shop scheduling problem. So everybody knows that job shop scheduling problem is the NP-full mathematical problem that has no deterministic algorithm to resolve it. So it's like only suboptimal solution that you can come up with. And what it may be, I mean, it depends. But just by looking at this data, when you have some constraints, like I have a processing times per job on the machine, I have machines, I have jobs, and I need to kind of dedicate jobs to be executed on certain machines. And at the same time, I have constraints about what job and what will be the precedence of the execution. Like this task for this job gets executed on machine number 2, and then only after that on machine number 0 or something like that. So all these are constraints. So how can I resolve this type of problem and say at which point in time each task has to be executed and each job has to be executed on which machine? And I also want to minimize the total time span, because I mean I want this to be as condensed schedule as possible, so optimize my resources. So for this purpose, I use Solr Foundation and Excel add-in for Solr Foundation, and I build a model which looks ultimately like this. And it's, as you go through different parameters, so this is all parameters bound to Excel spreadsheet. And I have decisions based on make span and X and Y, and I have a goal to minimize make span, and I have bulk of constraints. And bulk of constraints, again, implementing the precedence, different precedence constraints, and you see that I can use what is called OML, the optimization modeling language, to express my constraints. So this is the implementation of mathematical model, which is just this. So when I have my minimization of all make span, I have a different type of constraints based on no overlap. I don't want my jobs to overlap, of course. It's not acceptable. I need to honor all the precedence rules, and I need to somehow formalize how I represent my data. So let's say Y with indexes, it's like when job J comes after job K on machine M and things like this. So that's what Y means, and X means basically the start time on task running job J on machine M. So that's X JM. So mathematical model is here. Implementation of this using Excel Solr Foundation add-in is here. Solr Foundation, of course, provides you the API, which is exactly what's being used by Product Configurator in 2012 R3 behind the scenes. And as I resolve this model, it gives me, basically this is the result it gives me. It gives me the total make span, which is like 55 minutes for all my jobs. It gives me basically how much each job on each machine will take in terms of time, 6 minutes, 16 minutes, blah, 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 all that stuff. And it gives me that Y means that job 1 comes after job 2, or like job 1 is prior to job 2 on machine 1, on machine 0. Is this true? Yes. If I take this data now, and all this takes, in terms of the resolving, in just a few seconds. So I'll show you that in a second. But now if I visualize my machine, I can take a look at this schedule from like a jobs on the timeline perspective. This is how my jobs are distributed on the timeline, and this is how my machines are loaded. So that's machine load for the day, for let's say 55 minutes of my time, or maybe 55 days. It's essentially up to you. So if I want to resolve this model, all I need to do is to click solve, and it starts solving this, and here's the result. So within a matter of how many seconds, maybe like 1.5, 2 seconds. It gave me that my make span is 55 minutes. It applied this algorithm based on Gurobi solver. It says that the solver is basically the solution is optimal, and it gave me all this indication that I can then visualize and do some very, very cool stuff with it, analysis. And if I wrap this up as with the API into, let's say, web service, or just a service that is deployed like somewhere for consumption from Dynamics AX, I can then use this for job scheduling and resolve something which you can only dream about within a few minutes of time. So that's almost all I have. I also had example on Project Siena and the way you consume data in Project Siena. If you know the Project Siena, it allows you to build your own modern apps by yourself. And there's a support for RESTful services as well as mobile services, and it's going to be as a part of app services. In Azure, it's going to be support for Dynamics. There's the Dynamics CRM connector that allows you to consume Dynamics CRM data in a secured way in Project Siena. So I'll probably skip this for the purpose of time, and you can find my videos about Siena separately and several presentations that we did over the course of last few years. And for dessert, and this is truly 5 minutes, I will show you a quick example of the smart glass technology and how this applies in the industrial scenario. I promise it's just 5 minutes. And what I did, I prepared a video that I will play, and I will just narrate as I go. So hopefully this will allow me to, one sec. Sign out, and then sign in again. So just 2 seconds of explanation. I'm a field service technician. I'm using Dynamics CRM and the smart glass technology, the glass that was on my table at the beginning of the presentation. And my machinery sends me a maintenance request for the HVAC repair. So what I do, as a service dispatcher, I can use big maps to visualize where my technicians are in the world, and I can assign right technician to the right job for the repair. So I'm looking at the checklist for the repair, which is associated with the service case in Dynamics CRM in this case. It has a number of checklist activities associated, like air filter check, burner condition check, electrical connection check, and I want to make this available on the glass. So somebody in the field wearing just this wearable, the glass, will be able to see this in front of somebody's eyes. And I also have a media and documents which somebody may see the picture of the repair parts required, or maybe even a video of how my HVAC unit, so I'm hosting this on Windows Azure Media Services, and imagine that this becomes available on the glass. And you will see how I'm wearing the glasses, how I can see what's going on. So I put my glasses on, and this is what I see through them. I'm just using emulation software, but that was a real live demo at Convergence. So I'm seeing the first task, and just with the head movement, so I don't touch my glass by hand by any means. Just by using my head movement, I can navigate just like you're doing Kinect, like Kinect navigation with the hand, but this is like moving your head slightly. You can navigate to the elements of the UI, which is almost, I mean, it's floating in front of your eyes, overlaying what you see. So you still see the factory behind, and you see what you're doing, but it's just floating like a semi-transparent user interface element. So you saw how I completed the first task, and now I want to take a picture of my broken equipment, and I want to send this back to Dynamics CRM. So this will be attached to my checklist record in Dynamics CRM. So my supervisor may just take a look at what I'm doing. So this is a picture taken. You saw the small preview that showed up on the glass as well. So my next step, let's see what I'm doing next. I guess I will go and complete the next task, which is electrical connections. Or sometimes I need somebody's help, or maybe I need to see the video instructions. So this is streaming on the glass. This is streaming video live from Windows Azure Media Services. And I will expand this full screen, take a look at my HVAC unit so I know what I'm doing now, how it looks like. Maybe I have having difficulties finding this in the factory. So I watch the video, which is great. And let's see what I'm doing next. I guess I complete this task, and the last task pops up. But I truly need, for the burner condition check, I truly need somebody's help, so I'm stuck. So what I do, I call somebody who sits at his desk or her desk at the office, and then somebody takes this call at the office, and then somebody sees what I see through my glass, because my glass is equipped with a camera that allows me to take a picture, video, and stream the video to somebody's desk. So now that somebody is pointing me to where I have to work on, like drawing arrows or drawing circles, and if I switch back to the glass view, you will see, okay, here it is. I mean, I need to work on this because that's what this person maybe hundreds of miles away from me drew on my glass in front of my eyes, which is, again, unbelievable by itself. And as I watched and as I communicated with this guy, and it's a real call, so I spoke with the headphones. I can speak with somebody, and then somebody sees what I'm doing. And as I completed this scenario and complete the last task, the system will tell me proactively, like, okay, so you probably have, and I do have a VIP customer that I have to visit in the same area, so I have to go and have business lunch, and maybe that's my next job assignment. That's what we showed live at Convergence. And of course, now if I go back to Dynamics CRM, and the same scenario is implemented in Dynamics AX in the service module, now you see that the column done has indication that everything was done by myself in the field, and my supervisor is looking at this at his office. And this is the picture that I've taken. It's attached to the business entity in Dynamics CRM. So that's essentially, like within 5 minutes, that's essentially the scenario that I had on the smart glass. And this applies to different areas as well, such as warehouse. Let's say you like the quality management, when you have to scan barcodes and take picture of damaged goods and things like this. Or on the shop floor when you want to execute some job with having your hands free. So this is a lot of value, and according to Gartner, specifically by 2017 in the field service domain and industry, it may be billions of dollars saved from leveraging this technology. So for this technology, again, it's a beginning of times, and it's evolving very rapidly and gaining popularity. And special thanks to APX Labs for developing software and partnering with us to deliver this kind of exciting functionality. And we hope, and I hope, that all I showed you'll be able to embrace very quickly, and hopefully you got some interesting and new, fresh ideas from me on how Microsoft delivers in an era of Internet of Things, connected devices with a variety of different services, devices, and solutions powered by Dynamics. So I guess with this, I will stop. And back to you, Jason.
Yeah, thanks, Alex. Nice work. You really covered a lot of ground there in the last 80 minutes or so. And we do want to take a couple minutes here for questions. We had a couple of people asking about access to the slides and the recording. So I would just note that we are recording this. We will make a copy of the recording available. Alex, if people want access to some of these materials, what would be the best way to inquire about that? To write to you directly?
Yeah, so the slides, I can provide you with a slide deck, and you can, if there's a way for you to kind of put this next to the event explanation, like on the same web page, so that's no problem. If you have specific inquiries in terms of like getting some of the materials, you can write me directly, or you can write Jason. We can accumulate requests, and then I can do some kind of distribution list kind of sent out of those materials. And many of those materials you will also find in the next coming few months on my blogs as well. So if you watch my blogs, you will see this and many more. But definitely I will be glad to share my templates and materials with you even now.
All right, excellent. Yeah, and I can see a couple other people voting on that.
And my email is this. So again, as you prefer, writing me a message or writing Jason a message, and then we can accumulate like different types of requests, and then I will just do the send out and supply you guys with the hopefully the material that you liked.
Alex, you mentioned demand forecasting for AX 2012 R3. Is that something that people can start taking advantage of now, or is that something down the line?
Yeah, it is available right now. So in Dynamics AX, in the master planning area, so the demand forecasting is available. So just like I was explaining, it's all there. It's a part of our pre-release. And all the algorithms that I explained, ARIMA, ARTXP, as well as mixed algorithm, it's all available in R3.
All right, excellent. And are there any other prerequisites for that? An Azure account or other things that a company has to do to really make that work?
No. So just a quick word about architecture. So the demand forecasting, it's like three main components. So of course, Dynamics AX with the functional coverage in terms of like producing inventory forecast. So the AX, if you have AX, that's prerequisite, of course. The second component that you have to be aware of is the cube, the demand forecasting cube that gets deployed and supports demand forecasting functionality. And as a part of demo image, you have this all pre-configured and pre-built, so no work at all. And the third component which is used is Excel. And basically, from Dynamics AX, you initiate the creation of the data in the cube. Then you use Excel to visualize and change the data, the forecast that gets produced. And then you come back as you complete your work with the adjustments in Excel. It gets published back to the cube, and then from AX, you just push it from the cube back to inventory forecast, being the demand forecast. So all this is a part of R3 release, and the demo image has it all. So for you, it's just a matter of few clicks to try it out if you use Demo VM.
All right, we have a question here. Are there aspects of what you showed today that would be available or applicable to NAV?
So in general, everything that I showed, like Azure services, it is applicable to NAV. So I can easily build templates because ultimately it drills down to services available in the cloud as well as the data and the workloads you want to implement. So I would say, I mean, I can come up with the scenarios similar to what I showed, and just having NAV using basically in this section, I can put NAV, and transformation of your business applies as is, and the connection to devices and the cloud applies as is. But just NAV becomes like a beneficiary of all this set of services. So the answer is yes.
All right, a question here. Can legacy machines be fitted with devices that generate data?
Good question. So of course, like in our digital age, I mean, if you have a digitized equipment, it's much more easier because they come already with connectors and with the interfaces to collect the data natively, and they are running like operating systems and so on. And for the older equipment, which is totally fine and totally anticipated especially in the manufacturing industries. So we have basically we have different partners in our channel working with us, and I will just name the company is called Memex Automation. So they have extensive experience in building and collecting data from like more analog type of machines, and they have experience with the different connectors. They can install those connectors to old school machines and digitize them and collect the data the way you collect from the modern equipment. So it's just additional step to kind of put the connector in place, and with the sensors and so on, just like I did with my robot. And then you have a data that you can place anywhere, let's say in the cloud, and from there you have an open door to any other Microsoft services available in Azure.
All right. I think we are at the end of our question queue here. Let me just remind folks, we do have a little survey that will pop up after today's session. We really appreciate you taking 30 seconds or so just to give us feedback on what you thought, how the webcast technology performed, those kinds of things. And as we do wrap up here, I'm going to see if there's any other questions. If not, yeah, Alex, thanks again for joining us again. It's always a lot of fun to see what you've been working on and to hear about some of this cool stuff.
Thank you for inviting me, Jason, and I hope to be back soon.
Yeah, well, we hope so too. With that, also thanks to everyone in the audience for your attention today, for your questions. We are going to end there, and have a great day.
Thank you very much. Thank you for joining, and enjoy the weekend. Bye.
Bye.